Hi everyone, welcome to this module. In this module, we're going to be talking about Kubernetes and why is it a big deal in today's world. In this module, you're going to learn what is Kubernetes, and also you're also going to understand the historical evolution before Kubernetes. In other words, we are going to learn how it was before Kubernetes came into the picture. Then after that, we're also going to understand some of the problems that Kubernetes is trying to solve in today's world. And also, we're also going to understand, what Kubernetes can actually do for you. And lastly, we're also going to understand the why behind its popular adoption. Why are companies adopting Kubernetes? What is Kubernetes? If we go by the official documentation of Kubernetes, Kubernetes is a portable, extensible open source platform for managing containerized workload and services that facilitate both declarative configuration and automation. Now, I'm going to use my own word. Kubernetes is a platform that helps us to manage, scale, and deploy large scale of containers. Now, Kubernetes is used to manage, and also orchestrate large scale of containers. When you have thousands and hundreds of containers, it is very advisable to start using Kubernetes. And that is the strength of Kubernetes. Now, if you don't understand this, by the end of this video, you're going to have a good impression or a good understanding of what Kubernetes is and what problem Kubernetes is trying to solve. But before then, let's understand the historical evolution before Kubernetes. Now, we have three eras before Kubernetes. The first one is the traditional deployment era. The second one is the virtualized deployment era. And the third one is container deployment. Then after that, Kubernetes came in. Now, let's take it from the first one, which is traditional deployment method. In the traditional deployment method, what happened is that whenever a company or an organization wants to deploy their application, they buy a server, install an operating system inside the server. The operating system can be Linux operating system, it can be Windows operating system, whatever operating system they want to use depends on their use case. Then after that, they run the application directly on top of the operating system. But this came with loads of issues. And one of them is that since all the applications are running on top of the same operating system, there might be a case whereby one application can be using more resources than the other. Let's say, for instance, one of the applications is having memory leakage, whereby the application is consuming more memory than needed. Now, what happened is that application, because it is consuming more memory, is going to starve the other application of resources, which can lead to chaos amongst all the applications running inside the system or on that host. So because of that, a technology needs to be invented whereby all these applications needs to be isolated from each other, whereby one of the applications is not going to affect the other ones if they are running in an isolated environment. Now, that brought about the virtualized deployment. In the virtualized deployment era, this is the era of virtual machines and virtualization. Now, in this era, we now have one physical computer or one physical host or a server being virtualized to have different virtual machines. And each virtual machines can then run special or specific applications. Now, in this case, all the applications are isolated from each other because they are running on different virtual machines. And then these virtual machines are completely isolated from each other, whereby one application cannot see the other application. If one of the application is compromised, it does not affect the other because they are in a completely isolated environment. And on top of that, each of the virtual machines have their own operating system. Now, one virtual machine can be running Linux operating system, the other can be running Windows operating system, the other one can be running Mac operating system. But this also led to drawback. One of the drawback in this is that each application is running on a virtual machine. In a situation whereby you want to scale your application, it becomes very difficult and it becomes very, very slow for you to scale out your application. In today's world, where agility is paramount, whereby you just want to scale your application in just a second, it becomes very difficult for you to achieve this with virtual machines. Now, the reason is because virtual machines have a full operating system, which means that in the advent of scaling, you need to start booting from the kernel, start booting the operating system, and this can lead to more time for scaling your applications. Because of this, the container era came into place. In the container deployment era, we now have containers or applications running inside a container. A container is just like an isolated process. Now, each container runs on the same operating system and on top of a container runtime. All the container running on the same host utilizes the same kernel. Now, containers tend to be much more preferred to virtual machines because they scale very, very fast and they have slow boot time. A container can boot in just a second, but a virtual machine takes more than a second to boot because it has a full operating system. In the realm of DevOps, whereby we want to scale our application so fast, when traffic increases, we want to scale smartly and agile, then containers tend to be much more favorable. But then, containers also come with its drawback. Now, one of the notable drawbacks of container is that all container running on the same host utilizes the same kernel, which means that if one container is compromised, it's going to affect the entire operating system or the entire container running on the same host. You have one physical machine, you install your container runtime on it, and you start running your container on top of it. Now, at that point, you have a single point of failure, which means that if anything happens to that server, all your applications are gone, and which is not good. Now, companies are now looking for a way to spread their application or their container across different servers, and that is what bettered Kubernetes. What problem does Kubernetes solve? We're going to understand the problem that Kubernetes solves now. Now, with the rise of microservices, that also led to the rise of containers. Because containers tend to be the go-to choice for running your microservice application, because containers tend to be much more efficient, lightweight, and they are consistent across different environments. Now, this portability provided by container resulted in hundreds or thousands of containers being used to build and run applications. Now, because of that, Kubernetes came into the picture to help and manage and scale large number of containers used by our applications. Now, when you see an application having hundreds and thousands of microservices, it makes sense for you to use a container orchestration tool like Kubernetes to manage and scale this container at a large scale. Now, what can K8s do for you? Now, let's understand this conceptually with good example. Number one, scaling. Kubernetes helps you to scale your application smartly. Now, if you compare this to the traditional Docker method, where you are running your application as a Docker container only, if you want to scale your application, you need to start running a different container by running a command and etc. But with Kubernetes, with just a simple click of a button or even a declarative manifest YAML, you can scale up your application. You can scale up or down your application. And to make it more efficient, you can even leverage auto-scaling to scale your containers running in a Kubernetes environment. The second one is high availability. Now, because your containers are spread across different virtual machines in a server, your application tends to be very much highly available. Because if you have different replicas of your application, the chances that all the replicas are running on one server is slim, which means that if one server goes down, you still have other replicas of your application running on different server or different hosts. The third thing is self-healing. Kubernetes have the intelligence to restart itself, to restart containers or pods whenever something happens to them. Now, this comes with the intelligence of Kubernetes, which is liveness and readiness probe, which helps Kubernetes to determine if an application or a container is running or not. If the application is not running, Kubernetes restart the application and you have the application up and running. The next one is service discovery and load balancing. Kubernetes helps you to discover the endpoint of your application and also load balance traffic across those targets. And the next one is automated rollout and rollback. In the advent of you deploying a new version of your application and that application is having hard time or that application is not running, you can easily roll back with Kubernetes with just a one-line command. And the next one is secret and configuration management. Kubernetes comes out of the box with config map as secret that helps you to manage sensitive credentials and also configuration files. And that is exactly what secret and configuration management does in Kubernetes. And also, Kubernetes gives you the ability for you to provide your own storage solution. You don't need to worry about how to provide persistent volume to your containers running in Kubernetes. Kubernetes abstracts this from you by giving you the choice to plug in any solution that you need to manage or to provide storage to your containers. This could be using EFS. This could be using Rookserve. It can be you using AWS, EBS, CSI driver. Depending on what environment you want to run your Kubernetes. And also, Kubernetes helps you to manage resources on your cluster. It enforces limit on those containers, which means that if your containers or pod are using more than that, automatically Kubernetes is going to kill them and restart them again. So these are some of the things that Kubernetes can actually do for you. Although there are more than these, but these are the main ones. Now, what is the why behind its adoption by company? Why are company adopting Kubernetes? Which is the why behind the adoption? Now, we have different solutions out there, but Kubernetes reigns supreme. Now, one of the reasons why Kubernetes is widely used by companies, number one, is because it is open source. Number one, since it is open source, it is free, it is customizable, it is based on what the community needs, which makes it really, really flexible and also much more secure. And also, Kubernetes can run anywhere. It can run on virtual machines, it can run on the cloud, it can even run on your local computer, or you can even run it on containers. So you can see one of the reasons why Kubernetes tend to be favored by different companies or different individuals because of this flexibility and customizability. Now, this is the end of this module. In the next module, we're going to be exploring Kubernetes architecture.